So now we've been talking about monatomic ions. So ions are just one atom, made from one atom, composed of one element. In this section, we are going to talk about polyatomic ions. So ions that are made from more than one atom or element. Sorry, atom or element, I guess. So in these cases, the compounds are, or the ions are made from a combination of atoms of different elements, and they have an overall charge, meaning that collection of atoms has either gained or lost electrons. So we make polyatomic cations, which are positive ions that have more than one atom in them, or polyatomic anions, which are negative ions that have more than one atom in them. We're going to see these a little bit more when we talk about covalent bonding, because these are covalently bonded together. But since we're doing ionic compounds, we need to introduce them now. So if we look, we can see. Oh, do I have my pen going? Yep. Okay, so we can see that a typical cation, and one of the only really cations we're going to see, polyatomic cation, is NH4+. That's nitrogen with 4 hydrogens bonded to it, and an overall positive charge. So basically that's nitrogen with 4 hydrogens bonded to it that has lost an electron and is now overall positively charged. So the nitrogen and the 4 hydrogens are bonded together. It overall carries a negative charge, so it will form ionic compounds with anions. And then a typical polyatomic anion is phosphate. So NH4+ is called ammonium. That's the ammonium ion. PO43- is called the phosphate ion. The phosphate ions are really important in life, in your body functioning properly. It's how energy gets moved around a bit. The phosphate ion and its daughters, I guess, or yeah, siblings, hydrogen phosphate and dihydrogen phosphate. So PO43- is a phosphorus with 4 oxygens bonded to it that now has gained 3 electrons. So that whole system has gained 3 electrons. So that whole system together as a unit is an anion. Okay. Most polyatomic ions that we're going to see, basically except for ammonium, are going to be anions. So this is the list of anions or polyatomic ions that's in your book. These are the ones that I'm going to expect you to know. These are the ones I'm going to use through the semester. So we have acetate, which is this, CH3CO2, and that's got a negative charge. Hypochlorite, which is ClO-, and so on. So you can see the formulas and the charges for each of these polyatomic ions. Notice there's 2 positive ones, the ammonium ion and the hydronium ion. Hydronium we'll deal with when we get to acids and bases. For other things, for ionic compounds, that we won't be using it. But we'll see that later on. So really, the positive ion that we'll be dealing with when we're talking about ionic compounds is the ammonium ion. And then the anions, we'll be dealing with all those. So there'll be a sheet posted of the ions that you're going to need to know. The polyatomic ones and the monatomic ones will be on there. That list will give you the ions you need to know. All right. So let's talk about ionic compounds with polyatomic ions. So we have the question asks, what is the formula of a compound that contains potassium ions and nitrate ions? Okay, so potassium ions are going to be the metal ions potassium. That's going to be the K+ ions, because the potassium are alkali metals. They occur in the first column, so that's going to be their charge. And then nitrate ions, we just saw nitrate on the table before, NO3-. So when you are dealing with ionic compounds or naming or whatever, you may want to print off that list of ions to have it by you until you learn them and know them by heart. So This is going to be this, when we form compounds, ionic compounds, we want to make sure we have the same number of positive and negative charges. Potassium is 1 plus, nitrate is 1 minus. So the formula for the compound, the ionic compound that forms between potassium and nitrate is KNO3. 1 potassium and 1 nitrate. And that's how we write it, just like that. We know it's an ionic compound because it starts with that metal there. That's kind of a dead giveaway of an ionic compound. If it starts with the metal or the ammonium ion, because that's another cation. But KNO3 would be the compound that contains potassium and nitrate ions. Okay? So now we've got calcium ions and hydroxide ions. Calcium are Ca2+, and hydroxide are OH-. So hydroxide is the polyatomic ion here. So here we see, to make a neutral compound, we have 2 positives from each calcium and only 1 negative from each hydroxide. So clearly we're going to need 2 hydroxides to give us 2 negatives that will neutralize, or that will balance off our 2 positives from the calcium. So when I write this, I need calcium, 1 calcium, and then 2 hydroxides. To show that we need 2 hydroxides, we're going to use parentheses. So whenever we need more than 1 polyatomic ion, we're going to put it in parentheses and put the number we need outside the parentheses as a subscript. So this says in a crystal of this compound, which is called calcium hydroxide, we're going to have 1 calcium for every 2 hydroxides. That parentheses tells me I've got 2 of everything in that parenthesis. And the thing in the parentheses is hydroxides, so 2 of them. Okay? Now we're going to do ammonium ions and hydrogen carbonate ions. So ammonium ions are NH4+, 4+, and hydrogen carbonate are HCO3-. So you can see that there are the charges of the ions are the same, so you can just put those together 1 to 1. So I'm going to get an NH4HCO3. Notice I don't put the H's together. I don't write NH5CO3. I don't do that. I keep them as the cation, the formula for the cation, and the formula for the anion separate. So I can see that and look and tell that it's an ionic compound because it's got ammonium in the front and then hydrogen carbonate in the back. It's also going to make it a lot easier for when I got to name them if I keep them separate and not mix all the elements. Okay, last one, aluminum ions and sulfite ions. So aluminum ions are Al3+, and sulfite ions are SO3 2-. Okay. So I've got 3+ and 2-. If I put those together 1 to 1, I'm going to have more positives than negatives. So I'm going to add another negative ion, which is the SO3 2-. So now if I put 1 aluminum with 2 sulfites, I've got more negatives than positives. I've got 4 negatives and just 3 positives. So I'm going to need another set of positives. So now there's 6 positives and 4 negatives. Clearly I'm going to do more negatives. So now there's 6 negatives, 2, 4, 6, and 6 positives. So to make a compound where I've got the same number of positives and negatives, I need 2 aluminums and 3 sulfates. So since aluminums are one element by itself, I can just do, well, that's wrong. Let's try that again. I can just do the aluminum with the 2 subscripted. But for the sulfates, since they're polyatomic ions, or sulfites because they're polyatomic ions, I'm going to do parentheses, SO3, and then 3 outside. So the compound that forms when I combine aluminum ions and sulfite ions is going to be aluminum sulfite. Looks like that. And the formula is Al2SO33, where that 3 on the outside of the SO3 means I need 3 SO3s, and the SO3s are 2-. Okay, so a crystal of that, for every 2 aluminum ions, there'll be 3 sulfite ions. And that's the end of this. So that's the introduction to polyatomic ions.